Welcome to another video of Vidhai. Now we are going to see some practice problems of the chapter Light, and I am a volunteer from the Vidhai Exams Possible team. Without further ado, let's go on to the practice problems.
Alright, so now we are going to practice some problems on the chapter Light, and these questions that I have taken out by hand is from the previous year question papers of NMMS. Alright, so with that being said, let's move on to solving this question in hand. Now let's see the first question. The first question says splitting of white light into its 7 constituents colors is called what? So we know from the slides that we have seen, is in the last slide especially, we know the answer is going to be dispersion. This is a theory question, so the answer is dispersion. Look at the slide of the last slide that I have given. Now let's move on to the next question. Now on to the second question. The second question is the shining of a diamond is due to what? And the answer to the second question is not refraction, but rather its total internal reflection. I made a small mistake, but the answer after I corrected myself is total internal reflection. That's the answer to the question. Alright, now going towards the third question. Dash mirror is used by dentists. Now this question is also shown in the slides, and the answer to this question is concave. This is also the theory, and I have discussed that question in the slides as well. Now this is quite a tricky one, so we have to choose the correct pair from given 4 options. So the first pair is concave mirror and ambulance. Then the next is convex mirror, solar cooker, Newton's disk, car headlamps, rear view mirror, and dispersion. We know that dispersion and rear view mirror is not the correct answer, because the dispersion question we can see that it's the splitting of 7 colors, and the rear view mirror, which is the convex mirror, will not split the light, so that's not the correct option. Neither is this, because the car headlamps require concave mirror, and Newton's disk is neither a mirror, it's just an object, a disk of all 12 colors in it, which is not the correct pair. For the B part, convex mirror and solar cookers. We know solar cookers is of concave mirror and not convex mirror, so this is concave, and so this pair is wrong, and the only pair that we are left with is ambulance and concave mirror. This is the correct answer, because ambulances have headlights which have concave mirror, and that's pretty much it. Even the sirens have concave mirror, which allows the light to go further into the distance. Now with that being said, let's go into some practice problems. Alright, to the practice problems. We have the first question, the fifth question, as find the focal length when the radius of curvature of the sphere is 30 centimeters. So let's draw the spherical mirror. The spherical mirror here could be both concave or convex. Both the cases will give the same answer. We know the radius is 30 centimeters. And when we draw the line of the mirror, we have the pole, we have the focus, and we have the center of curvature. We know the distance from the center of curvature to the pole is 30 centimeters, which is equal to radius of curvature. And they have given us to find the focal length of the mirror. So this is the focal length of the mirror, which is denoted by small f. Now the question is to find f. We know for a fact that distance between CP is equal to twice the distance of FP. We know CP is equal to 30 centimeters. So 30 centimeters, right, is equal to 2 of fp. Here fp is equal to f, so f, and we can get the f as 15 centimeters. So the formula that is required here is r is equal to 2f. This is the formula that is required to solve this problem. While the r is the distance between C and P, f is the distance between F and P. And these two distances are same, so F is the midpoint between C and P. Now let's go to the next question. Both mirror focal length is equal to F. What is the value of D in such a manner that the images formed by both the mirrors will be 1? Well, we know the image formed by this mirror will give an image 1 and this image will give an image number 2, but they have given for which only one image is formed. The only possibility when two images form as one image is when they coincide with each other. That is, you have an object here, that's image 1. Now if I draw another ball on the same as ball number 1, the image 2, it will show as one image, but both image 1 and image 2 are two different things, but they are coinciding, so it appears as one image. So let's try to use the same thing on here. Given that S is equidistant from both the mirror, so we have S here, this length will be D by 2, so this is the concave. And the same manner, this is S, this will be D by 2. That is a case where we know an image placed at a certain point, the image will also be at the same point, and that case is when the object is at the center of curvature. This is the concave mirror, by the way. So when the object is at the center of curvature, the image will be formed on the same place. So D by 2 is equal to the center of curvature. So the distance between the pole 1 or even pole 2, the distance between P1 to S is same as going to be the R. If you notice in this problem, the pole to the center of curvature distance is equal to R, which is equal to R. So we can get the formula of D is equal to twice of the radius of curvature. But the given data is in F, so we need to turn R into F. We already know R is equal to 2F, right? If we substitute this to this, you will get D is equal to 2 into 2F, which is equal to 4F. So D is equal to 4F. Now with that being said, we will go to the next problem of Snell's law. Alright, this Snell's law problem looks a little bit complicated, but it's actually easy if you follow the steps. So given that line AB and the line CD, that is these two lines, are parallel to each other, then what is the relation between mu1, mu2, mu3 and mu4? If you notice one of my slides, I given a tip that to assume a constant and then write a relation in Snell's law. That is, if I'm going to note this angle as theta 1 and this as theta 2, this will also be theta 2 and this will also be theta 1, because there's no change in these two interference. So we can safely assume that mu2 is equal to mu3, because the path between the mu2 and mu3, the line path has not been changed, but that's changed in between mu1 and mu2 and mu3 and mu4. So, and already given that the line AB is parallel to CD, we can also confirm another fact. But before that, let's write in the formula of Snell's law, which is sin theta 1 by mu 1 is equal to sin theta 2 by mu 2 is equal to sin theta 1 by mu 4. Now don't take the middle term, instead take the first and the last term. So you have sin theta 1 by mu 1 is equal to sin theta 1 by mu 4. We know sin theta 1 and sin theta 1 to be equal, so I can cancel these two and say 1 by mu 1 is equal to 1 by mu 4. Thus we know that mu 1 is equal to mu 4. We have another relation and we already got the relation here. That is, since there's no path difference, it's the same thing. You can even draw a normal here and say this is theta 2 and this is theta 2 and derive this one in the same manner. For this one, it's going to be sin theta 2 by mu 2 is equal to sin theta 2 by mu 3. This is the Snell's law, and thus we can actually find mu 1 is equal to mu 4 and mu 2 is equal to mu 3. So in this thing we can conclude that, let me draw the layers again in a bigger manner. So we have a light layer like this, alright, and then it refracts. It still goes in the same manner, there's no change there, but then it again refracts such a manner that this line and this line are parallel. So if I extend this, you would see this line and this line to be parallel. Now whenever there are two rays that are parallel to each other when being refracted, apparently being parallel, we know 1 and 4 mu should be same. For 2 and 3, if there's no apparent change here, then mu 2 and mu 3 should be same. So wherever the light rays which are parallel to each other, the mu should be same, and when there's even no change between the interference, their mu also should be same. We can see this example in the refraction of glass slab. You can assume the mu 2 and mu 3 as a slab like this. Now if you see this as a glass slab, you can see these two are going parallel to each other like the air. These two are air surfaces and these two are glass surfaces. So mu 1 and mu 4 is equal and mu 2 and mu 3 is equal.
With that being said, we have completed the chapter light, whatever we are supposed to study. And also do check out other videos in this channel as well. Thank you for attending.